Dear students, very good morning. Previously in the classes or in the online classes, you have studied about the different types of statements. A statement is nothing but it is an instruction given to your computer. In that, multiple types of statements are there. We have come across sequential statement, conditional statement, looping statement. Okay, now we are focusing more on the conditional statement in today's session. So let us have a brief introduction about it. A conditional statements are the statements wherein which it gets executed depending on the condition. In the sense that a statement will be executed depending on a particular condition is satisfied or not. There are different types of conditional statements. You have if, you have if else, you have else if ladder, you have switch, and you also have nested if. These are the different categories of the conditional statements we have. Let us have just a brief view. A simple if is a conditional statement wherein which if you have one alternative, okay, or one option, then we can go for simple if. If you have two different options, then we can go for if else. If you have multiple options, then we can go for else if ladder. Similarly, switch also it is a multi-base selection statement where we have multiple options, but that options are having a unique value. Then we can go for switch. And nested if when we have multiple conditions to be satisfied to execute one particular statement. Okay, remember when multiple conditions has to be satisfied for one particular statement to be executed, then we can go for nested if. This is about a brief introduction of the conditional statement. Now in today's session we'll discuss about one such conditional statement application with respect to a particular program. The program goes like this. Okay, Mr. Varun is a player, is very much interested in sports. Okay, so what exactly Mr. Varun is going to do means Mr. Varun is going to throw a ball with some particular speed to the sky. Okay, he throws a ball with some velocity onto the sky. After reaching a particular height, the ball falls down. Why exactly the ball falls down? It's because of the gravity of the earth. It falls down. Now we need to find out the time taken. Okay, given the velocity, given the gravity, what is the time taken, okay, to come back onto the ground? That is the question here. So to know this particular time taken or to calculate this particular time taken, mathematical equations are very much important. You have come across many mathematical equations. You maybe would have been astonished why exactly we are solving these kind of equations. So one such equation is your quadratic equation which you have studied from your school. So to know the time taken, we can calculate that with respect to your quadratic equation. That is what is the question. So a ball is thrown straight up from the ground at a particular distance with some velocity. After some time the ball has to come back to the ground. At what time the ball hits the ground? So to solve this, we should make use of the quadratic equation where given the height, velocity and the gravity. That means given with what velocity Mr. Varun is going to throw the ball, what height the ball goes, and again at what is the gravity of the earth, it comes down. So the equation can be represented as gravity into 2 square plus velocity into t plus height is equal to 0. This equation may be somewhat difficulty for you since you have the terms gravity, velocity and height. But with the simple representation, if you remember, the quadratic equation, we have ax square plus bx plus c is equal to 0 where a, b, c are the constants. And the roots of this particular quadratic equation are x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. So now we have minus b plus or minus. That means we get two different roots. So those roots are x1 is equal to minus b plus root of b square minus 4ac divided by 2a. And x2 is equal to minus b minus root of b square minus 4ac divided by 2a. So now let us see what exactly the possible roots that we are going to get when we substitute the values of a, b, c. So first let us learn about this quadratic equation part. Later on we can substitute that with respect to the problem given gravity, velocity and height. Now if we substitute the values for a, b, c, the possible roots may be in the sense that if I give some values for a, b and c, what could be the possible results that I am going to get? See here, now let us consider example 1 where I have given the value a is equal to 1, b is equal to 2 and c is equal to 1. If you give like this, then the roots will be x is equal to minus b plus or minus root of b square minus 4ac by 2a. When you substitute the value of a, b and c, okay, you are going to get the value as minus 1. Why? Because minus 2 plus 0 is also minus 2. Minus 2 minus 0 is minus 2 itself. Okay, there is no change. Why? Because adding 0 or deleting 0 from a number will not have any effect. Okay. Now, what exactly we are going to see is when b square minus 4ac is 0, then both the roots, whatever x1 and x2, both the roots will be the same. Okay, you can see here minus 2 plus 0 by 2 is also minus 1. Minus 2 minus 0 by 2 is also minus 1. So this is first point that you need to remember, in the sense that whenever you have, okay, b square minus 4ac is 0, at that time both the roots will be the same. This is one substitution. Remember, this minus 1 whatever we have got, this may be negative value also, or the root may be positive value. It depends on the value of a, b, c. Okay, whatever the value of a, b, c, if you substitute, depending on that you will get the root values. If you give b as minus 2, then you will get the value as 1. You can just try and check. Now coming to the example 2, let me move towards the example 2. Okay. So the example 2, given the value of a is equals to 4, b equals to 1, c is equals to 1. If I substitute these values, I'll get minus 1 plus or minus root of 1 minus 16 divided by 8, that is equal to minus 1 plus or minus root of minus 15. So we are going to have square root of minus 15. This square root of minus 15 can be split into two parts using your mathematical formula, that is root of minus 1 into root of 15. Okay, so if you do that, root of minus 1, you know very well that it is imaginary value. Root of minus 1 is always an imaginary value. So you get minus 1 plus I root of 15. Okay, that means whenever the value, that is you have b square minus 4ac is less than 0, we get imaginary roots. That means the number is an imaginary number. We cannot tell exactly what is that value of it. So previously we had b square minus 4ac is equal to 0, we get both the roots are equal. If it is negative, that means if b square minus 4ac is negative, we get imaginary roots. The third example, let us go ahead. So a is equal to 1, b is equal to 4, c is equal to 2. X is equal to minus b plus or minus root of b square minus 4ac by 2a. When you substitute it, you will get minus 4 plus or minus root of 8 divided by 2. Okay, so when you substitute that particular values, you will get two different roots. Okay, x1 with a different value. Why? Because you are adding here plus, and x2 with a different value. Why? Because you are writing with respect to subtraction minus. You will get two different roots. So when you will get two different roots, when b square minus 4ac is greater than 0, we get real and distinct roots. These are the possible values. That means whenever you substitute a, b, c, either b square minus 4ac may be equal to 0, or b square minus 4ac may be less than 0, or b square minus 4ac is greater than 0. Depending on these tasks, now we need to calculate our problem, or we need to refer to our problem. So what exactly is the problem is, we need to calculate the time. Okay, the first thing is time is a real value. Time is a real value. It cannot be imaginary. Okay, it is a real value. Time, okay, your time can't be imaginary, or the time can't be negative. Remember this. Time should always be a real value, where that real value cannot be a negative value, or the value cannot be imaginary value. That means when we come across this particular case where b square minus 4ac is less than 0, where we get imaginary roots, at that time we cannot consider the time. So we need to neglect this. Now the options left out are when both the values are 0. That means, if b square minus 4ac is equal to 0, and if b square minus 4ac is greater than 0. These two we need to consider to tell or to calculate what exactly is the time and to display that particular time. Okay, so time cannot be imaginary, so we need to eliminate b square minus 4ac is less than 0. Now time cannot be negative, in the sense that if the value is 0, if b square minus 4ac is 0, or if b square minus 4ac is greater than 0, then we need to calculate. Okay, keeping that into consideration, so let us assume. So what exactly is the input that we need? The input we need is, we need gravity, we need velocity, and we need height. What is the output? So the output is we need to display time. So time may be T1 or T2 in the sense that if we go for real and if we go for real and distinct roots, two roots may be possible. Okay, and the two roots may be positive or one root may be positive or negative. That we'll see it later when we go for execution. So output is you need to display the time. Now, what is the processing involved in it? Okay, what is the processing involved in it? So what you are going to do? First, you are going to compute, okay, discriminant. What exactly is discriminant? The discriminant is the value b square minus 4ac. Okay, that is equal to b star b minus 4 star a star c. Now here we are not using b or a or c, so we are using with respect to gravity, velocity and height. So the b is your velocity, so I'll replace with v. Okay, the a is your gravity, I'll replace with g, and c is your height, I will replace with h. Okay, so first you are going to compute the discriminant. Once you compute the discriminant, after that the next step, okay, the next step that you are going to do is you are going to check, okay, whether this discriminant value, okay, whether this discriminant value whatever we have is less than 0. Okay, whether the discriminant value that you are going to have is less than 0. If it is less than 0, just display, okay, so it is invalid time. Why? Because if discriminant is less than 0, we get imaginary roots and it is an invalid. So imaginary roots we are going to get. That is why we are going to just display the time as invalid time and stop it. Now another option is if discriminant is equal to 0. Okay, if the discriminant value is equal to 0. If this is true, then what you need to do? You need to calculate just t. Okay, calculate t1, either t1 or t2. Why? Because both the roots are same. So t1 is equals to minus b by 2a, that is minus v velocity divided by 2 into g. Okay, this whole divided by, you are going to calculate t1. Now what exactly we need to do is, I told you this t1 value may be positive or negative. If the value is negative, then it is not possible for us to consider that particular value. So this t1 value whatever we have, it can be, okay, positive or negative. Okay, it can be positive or negative. So if it is positive, print the value. If t1 is positive, okay, print the time. Okay, otherwise you can print invalid time. Okay, you can display invalid time. So this we are going to check whether discriminant is less than 0. This we are going to check whether discriminant is equal to 0. Now the third option that we are going to have, option left out, is it should be greater than 0. If it is not less than 0, not equal to 0, the last option left out is greater than 0. At that time you are going to calculate t1 and t2. Okay, you need to calculate t1 and t2. How you are going to calculate? So t1, okay, t1 will be equal to minus v, okay, plus square root of d, discriminant whatever we have, discriminant, the whole content whatever you have, okay, this divided by 2 into gravity. Okay, this is plus. So now what could be the possible t2 value? So t2 value is, instead of plus square root, it will be minus square root you will get. Okay, so you will be having t2 as minus square root. Okay, t1 and t2. Now, so once you calculate t1 and t2, the possibilities are either t1 may be positive or negative, either t2 are positive or negative. So what we need to do is we need to check whether t1 and, remember, t1 and t2 are positive. Positive means if the value is greater than 0, then you are going to display both t1 and t2. That means the time may be any value. Okay, so again check whether t1 is positive. There may be possibility that only t1 may be positive or t2 may be positive. So we'll check whether t1 is positive. If it is t1 is positive, just print t1 value. Okay, next check whether T2 is positive. Okay, if T2 is positive, just print the T2 value. Otherwise, the last option is otherwise. Okay, otherwise just print that it is invalid time. Okay, just print invalid time. Okay, remember that whenever we are going to perform the operation, so first we need to calculate the discriminant. Depending on the discriminant value, we are going to do it. Three options are there. Discriminant may be less than 0, equal to 0, or greater than 0. So with respect to our application, so once it is 0, we need to consider if it is positive, and if the value is not imaginary, then only we need to consider the time. So that is why we are performing all these operations. Now we have less than 0, equal to 0, and greater than 0. Three possible options are there. So this we can implement by using simple if statement also, where checking individual condition. Or else, can we go for if else? No. Why? Because if else has two alternatives. So the next alternative left out is else if ladder. So we can go ahead with else if ladder. Okay, so now coming to the flowchart, let us see what and all the variables that we need to have. Let me see the flowchart. So start, declare GVH, that is your gravity, velocity and height. After that D, that is the discriminant, and T1 and T2 are the time. Now read gravity, velocity and height. So input is what? Gravity, velocity and height. After reading it, then you are going to compute velocity into velocity minus 4gh, that is the discriminant part. If discriminant is less than 0, then you are going to print invalid and you are going to stop. Since the space is not available, I have created a bubble and I will connect it to stop. Now, if discriminant is equal to 0, that means two roots are equal. So that is why I can compute either T1 or T2. Any one is fine. So I have given T1 is equal to minus V by 2 star A. Now, once you calculate it, if it is positive, then only we can consider the time. Otherwise, it is not possible. That is why I'll write. So if T1 is greater than 0, if it is true, then only I will print T1. Why? Because it is positive value. If it is false, I will print it as invalid. Now assume that if it is not equal to 0, the last option left out is it should be greater than 0. So no need to check the condition. Directly we calculate time 1 and time 2 with respect to the formula already we have discussed. After calculating, then again we need to check whether both T1 is greater than 0 and, remember it is and, T2 is greater than 0. If both are true, then I am going to print both T1 and T2. Any one time we can consider. Otherwise, if it is false, if T1 is greater than 0, then I am going to print only T1. Otherwise, if T2 is greater than 0, then I will print T2. So if both are negative, then I will print invalid time. And finally, I connect it to stop. You can also see the X that I had connected, I am connecting to stop. So this X comes from here. Okay, this X comes from here. So after D less than 0, imaginary roots, I will stop. Then after discriminant is 0, then after calculating the time, which is equal time, and if it is positive, I will print, I will connect it to stop. If it is invalid, I will connect it to stop. So this is what exactly is the flowchart for that particular program. Now let us see the program with respect to this. I have already declared the program. I have written the program. Now you can see the program is, we start with the header files #include studio.h. Now the another header file that you are going to see, math.h. Why exactly is this? We know that we are finding the square root. Okay, so we are finding the square root of that particular number. So whatever the mathematical functions that we have that are stored in the library math.h. Okay, so the library math.h contains mathematical functions like, it may be square root, it may be power, sine, cos, log, like this multiple functions are there. Since we are using square root in our program, I am using math.h. Now let us declare the variables as per the flowchart that we are going to have. Okay, you can see here the equivalent. So I am declaring GVH, D, T1, T2. Since all the values are real, I am declaring it as float. Then after that, we need to read GVH, that is gravity, velocity and height. So what is the equivalent read statement? The read statement is your scanf statement. But before that, let us add a printf statement. So the user comes to know that what exactly he need to enter. After entering, so now you can see that we are calculating the discriminant. So I have represented that in the equation format. Now after that, if D is less than 0, you can see that if D is less than 0, it is invalid time. So since three options are there, I told you we are considering else if ladder. So you're having if, else if, and again else. Remember, whatever the program we have, we can represent that in simple if. Here also I can write if d equal to is equal to 0. Here I can write if d greater than 0. Like this we can write the statement. Everything we can represent using simple if. But what happens is it will check all these three conditions. Okay, that means it will check d less than 0, equal to 0, greater than 0, whatever may be the content. So to avoid multiple verifications, we can go for else if ladder. Okay, so now any one, if this is true, it will never check these two. If this is true, it will never check the next one, like that. Okay, so now if d is less than 0, then it is imaginary roots, it cannot be considered. So we are going to print that. Now else if d equal to 0, I need to calculate t1. Okay, that is what I have written. T1 is equal to minus v divided by 2 star c. This is whole value. So now after that you need to check whether t1 is greater than 0. So we have two options, print invalid, print t1. So since we are checking the conditions, so two options are there. The best suitable conditional construct is if else. So I am using here if else construct. You can see if t is greater than 0, sorry, if t1 is greater than 0, then print time taken is t1 since it is positive. Otherwise print invalid time. Okay. Now this is with respect to d equal to 0. Now the next thing is very much important where we have multiple options. So the last option is if it is positive, then you are going to calculate t1 and t2. Okay, then if t1 is greater than 0 and if both are positive, then I need to consider any one value. So I am printing those two values. Otherwise, if t1 is greater than 0, I am printing only one value t1. Else if t2 is greater than 0, it is going to consider only t2. Otherwise print invalid time. Okay, so here again, since multiple options are there, I am using else if ladder. This is what exactly is the program. Now let me run this particular program and show you the different options with respect to whatever the values we are going to have. Okay, so if I am going to consider, so I'll compile the program name that I have given is p5.c. Okay, yeah. So enter GVH value. Remember, if I enter 1, 2, 1, okay, you can see it is going to show that it is invalid time. Why? Because 1 to 1 means previously we have solved, you will get -1, invalid time. But remember the same thing if I give 1, -2 and 1, see the time taken is 1. So if the B value, okay, B value is negative, okay, then what happens? Minus of minus bit will be positive, or else you can just print the D value also if you want. Okay, here I will print the D value so that you will come to know to which condition it is satisfying. Printf D is equal to %f/n, D, so that you will come to know what and all the value of D, depending on which you will come to. So let me compile. Remember, whenever you do any changes, okay, you need to compile the program. Yeah. So I enter 1, 2, 1. So you can see that what is the D value is 0. So D value is 0 means it will go to this particular case and it will calculate T1. But T1 value is what? -1. That is why it is not printing. But if the same thing, if I give A 1, -2, 1, you can see that time taken is 1. It is going to print 1. Why? Because it is positive. Similarly, let us try for other options. So that is, if it is imaginary roots. When it is imaginary roots, if A and C value is more compared to the B square, then root will get disappear. So 8 is there. I'll give 4 and C I will give 1. See, D value you are going to get -16. So it is imaginary time, can't be considered. Now the last option is with respect to your D greater than 0. So these options. So there can be three different possibilities. This, and this. I'll just give an example for all those content. Okay. So A I'll enter GVH. Now remember I'll enter 2, -8 and 1. Okay, you can see what is the D value? 56. That it is positive. So you will be having two options. So that will be, you will be having T1 also 3.8 and T2 is 0.12. So both are positive. Okay, this satisfies this condition. If T1 is greater than 0 and T2 is greater than 0. Okay, if you want, you can print separately here, T1 separately, T2 separately, and check. No issues in that. Now let me take another options. A value. I'll enter 1, -2 and -100. You can see that I'm having only one row. Time taken is only one. Why? Because you can just check here. If I'm printing printf t1 is equal to percentage f slash n, and again t2 is equal to percentage f slash n comma t1 comma t2. I'll just print it so that you will come to know about this easily. So gcc p5.c. Okay, let me run this. If I enter 2 minus 8 and 1, sorry, you will get, see, d is equal to 60 you are getting, t1 is 7.8, t2 is 0.2. So any one time we can consider. So if I enter if I enter 1 minus 2 and minus 100, so you can see that t1 is equal to 11 and t2 is equal to minus 9. So the time taken is, we are considering only the positive value, t1 we are considering. Now again I'll run this. Okay, I'll enter minus 4, 8 and 1. So you can see t1 is minus, that is negative, and t2 is positive. So we are going to consider positive value as 2.1108. This is what exactly is our program. See the quadratic equation, 3 different values that we may get with respect to your discriminant value, that is positive, negative and 0. So with respect to that, we are going to identify it and we are going to solve the problem. Thank you.